Hello and welcome to another LeetCode video. Today we're going to be working on letter combinations of a phone number. In this problem, you're given a string containing digits 2 to 9 inclusive, and you want to return all possible letter combinations that the number could represent. Return the number in any order, answer a mapping of digits to letters, just like the one on telephones given below. Note that 1 does not map to any letters. Okay. And so you are always given valid letters, and so you are always given valid digits, so you don't have to check for that. But how do we actually do this problem, right? So they do have this example where they show all the combinations, but how do we actually do this? So as you can see, it tells you there are combinations. I think it does anyway. Yeah, combinations. So combinations means we're going to want to look through everything, and we're just going to do backtracking. This is very similar to the combinations problem, I think yesterday or 2 days ago. It's pretty much the same thing, but there is like an intermediate step. So let's go through this. So let's say we have 23, right? We have these digits. So what we want to do first is we actually want to map every single number to the letters it can represent. So we can just have a hash map of and we can say 2 goes to DEF, right? And 3, actually, sorry, 3 goes to DEF. So let me get rid of that. So just do 2 actually goes to ABC. Okay. 2 goes to ABC, 3 goes to DEF. Okay, so now we need to return every single combination. So let's just kind of walk through what would happen. So essentially, at every single letter, we need to loop through every single letter in there and try to put every single letter into our current array, just like we did yesterday. And then once the array is long enough, we're going to output that to the result. So let's just see what that looks like. So let's write down our steps, and then let's just do a run of this. So we're going to have a function, and there's going to be a base case. So what's going to be the base case? So the base case is going to be when we are out of letters, right? So out of letters. Then we want to do what? We want to put the current combination into the result. Okay, now otherwise, whatever letter we are on, let's get the, or it's not actually going to be digits, all right? It's whatever, it's going to be whatever digit we're on. Let's get the letters for that digit and loop through them and put one at a time on the current. Then call backtrack, then pop. And so it's basically the same as the combinations, and let's just go through a dry run of this. So essentially when we're on a letter, so let's say we are on the first, let's make some colors here, and let's say this is this. Let's say we were on 23, right? So we're on the 2. So we call backtrack, we're on the 2. Let's just call backtrack, we're on the 2, right? Let's make more space here. Okay, so we're on the 2. Now what letters are in the 2? So it's actually A, B, C. Okay. And then let's just have a, let's keep track of what our current state is, right? So this is going to be our current array of all the letters, and then we're going to have a result. So let's just put the result maybe over here, res equals an array over here. This is going to take up a lot of letters. Okay, so we're on ABC and we're on 2. So we're going to say, let's just loop through this, and one at a time, let's put the letters into the current. So we're going to be on this A, which means our current is going to have an A now. Then we're going to recurse into B at index, this next index, right? So this is going to be the recurse. So we're going to just do index plus 1 or something. So we're going to go to 3. Now what's at 3? It's going to be DEF, right? And then in here, we're also going to be looping through this whole thing. So we're going to start at the D, and we're going to say, okay, let's put the D on this current. And then let's recurse one more time into B. And now we are in the base case. So let's just say this is, there is nothing here. Now we're just going to be taking this current and moving it into the result every single time in the base case. So that's what we're going to be doing in the base case. So we're in the base case. We're going to put AD in our result. Now we're going to recurse out back to here. And now we were on the D, but now we have to go to the next letter, right? Because we're looping. So we're going to pop the D, and then we're going to go to the next letter and put that on. So we're going to go to the E, and we're going to put the E on. And now we are going to recurse into here, and then we're gonna, every time we're in the base case, we just take whatever's over here and put that into the result. So we're gonna put AE on here, AE. Now we are going to back into here, and we were just on this letter, so now we need to go to the F. So now we're gonna go put the F in, and remember, before we put the F in, we need to pop the last thing from the current. So we're gonna put the F in, okay. Now we're going to go back down into the base case. So we're just going to be going back and forth here. And now in the base case, we're putting AF on here. We might need a little more space for the result. That's okay. Now we're going to recurse back. Now we are actually done with this loop, right? So we're done with this loop. So we're going to do this pop of the F, right? It's essentially going to be like push, recurse, pop. Okay, now we're going actually back into this state over here, right? So now we're back into this state. We recurse. This is like level 1. So this is level 1, level 2, level 3. We recurse back here, and we are done with this A. Now we're going to actually put in this. So remember, when we're done with the A, we're going to pop, right? It's push, backtrack, pop. Now we are over here. Now we're going to put the B in, and we're going to recurse down to level 2. And this is like a new whole function call here. So we're going to start at the beginning again. So this is going to be D. Then we're going to recurse into level 3, and now we're going to put BD into the result. Then we're going to recurse back to level 2. We are going to pop the D, and we're going to go to the next one. So we're going to go to the E, and we're going to push it into the current. Then we're going to go to level 3. So we're at level 3, which means we're going to put the result in here. Now we go back to level 2. We pop the E, and then we go to the F. Put that in. Now we have BF. Okay. And then let's actually give ourselves a little bit more space here. So let's get rid of this, and let's just say the result will go to, like, I don't know, over here or something. We'll add some more stuff. Okay. So now we're going to pop back to level 2, pop the F. And now we are actually done with this, right? We reached the end of the loop. So now we're going to go back to level 1. We're done with B. Now we're going to go to C. Then we're going to go back into level 2. We went into a new function again, so we need to start here. And so when we put on the C, we're going to put the C in here. Now we're in this function. We're going to put on the D in here. Now we recurse to level 3, so we're going to put CD in. So let's add CD here. Maybe we'll just like write it out over here. Oh, whoops. Didn't mean to delete that whole thing. Let's just delete this section here, hopefully. There we go. Okay. So now we are going to go back. We're going to delete the D. And then we are going to go to the next part. Didn't mean to delete the whole thing, but we are going to go over here now, put in the E, recurse down to level 3. We're at level 3, so we need to push the result. So CE is going to go over here. Now we are going to go back to level 2, pop. And then we need to go to the next level. We're going to go to F. Then we're going to go back down to level 3. And before we go down to level 3, we put this on. So we're going to put CF in here. And then finally, we go back to level 2, we pop. Then we are done with level 2, we go back to level 1, we pop. And we're done with this whole loop. So now we have all of our cases. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 different cases. And that's the same. And you should have 9 different cases. So that's essentially what our function looks like. It's pretty straightforward. Just at every single level you're looping, you have to map the digit to the numbers or to the letters it represents, and then you have to loop. Now the other thing I will say is when you have this cur array, it's important to have an array, because let's say you have a string. So this would be something really bad. Like let's say you have a string and your current string is like A, B, C, D, E, whatever, right? And now you want to add a character here. You want to make sure your cur is an array here, because to add a letter to a string, you're remaking the string. That's a big O of n operation, so that's going to be really costly. So what you want to do is you want to have an array of all of these letters, and then when you actually want to finally complete the string on this part here, you can just join the string. So that's why you want to store an array instead of storing a string, and because an array append is big O of 1, where a string append is big O of n. So what you're going to want to do is store an array and do your push and pops on there. And then finally, when you're ready to, get the word, then you can actually join the string. Okay, so now we have everything we need to be coding. So first things first, what we're going to do is we need to create a map of every single digit to every single letter. And I'm just going to write this in manually. You could probably, you could make a function for this if you wanted to, but I'm just going to write it out manually. And so what's going to happen here is we're going to have like a letters, let's say, equals, and then you're going to want to make a hash map. And it is also good to know how to like actually make a hash map with values, just in case you only use hash maps like you just only add and subtract, like get rid of digits, but you actually never made a hash map with key value pairs. So you're going to want like 1, and then you are going to want, actually 1 doesn't have a value, so it's going to be 2, it's going to have A, B, C, and then we're going to have 3, it's going to have D, E, F, 4, it's going to have G, H, I. And yeah, you could, like I said, you could obviously do this in a function because every single letter has 3 values. So J, K, L, 6, M, N, O, 7, peak, Q, R. Well, actually, the 7 does have 4 letters, so it would be kind of tricky there, but you could do it still. T, U, V. And this one also has 4 letters. W, X, Y, Z. So now that we have our letters, we need to make a backtrack function, and we need to make a result, and we need to, oh, there's one other base case here, and that's this one here. So if the digit is empty, you want to return an empty array because you're going to be pushing your cur, so you don't really want to push like an empty array onto the result. So you can just say if not digits, I believe if it's an empty string, it'll work. You can just return this. There we go. So now you want to have a result is an array, and you want to have a cur is an array. Now we want to make a backtrack function. So we take an index, and then we want to get the key value. So def, we want to get the key value here. And so the thing we actually need is we need this right here. This is what we need, right? So what we need is, but also the index is actually going to be in the digits, and it's going to be a string. So you're going to need to convert it. So you can say like key equals, well, actually, first of all, what you want to do is, no, actually, so this index will be the index in the digits, right? It's not going to be the actual value. It's going to be the index in the array. So the first thing you want to do is you want to check for if we're out of bounds. If we're out of bounds, we actually just want to be pushing the current to the result. So we could say like if index equals length of digits, we can do result dot append, and then we actually want to join the current on an empty string. So it's actually going to look like this, I believe. Join, and then you put in cur here. And this is essentially what it's going to do is it's going to take like the whole array of letters. So let's say if BD in an array, it will make it into a string. So you want to append that, and then you want to return here. Okay, now what you want to do is you actually want to get like the value here. And so the index is going to be the index in the digits, but we actually need, first of all, we need to get the number at that index, and then we need to convert that into an integer because these keys are integers, right? So like we would need to get the number at index 0, convert that into an integer. So let's do all that. So we can just say like key equals digits index, and then we want to convert that into an integer, right? So we can just say like, let's convert that into an integer as well. And then the value is what we really want. So the value is going to be letters key. Okay, there we go. Now the value is going to be like this whole string. Sorry, the value is going to be like this whole string. So if we're at, because the keys are going to be like 23 or something, now we have this key 2, and then we want this whole ABC. So we're going to want to loop through the whole string. So we can say like for I in range length value, let's just cur.append value I. Then we have to call backtrack. And where do we want to backtrack? We actually want to backtrack to the next index, right? So like, let's say we're at 23. Our first letter is going to be from the 2, but our second letter is from the 3. So this is index 0 and this is index 1. So you want to do index plus 1 here for the next index to read the next number, essentially. Okay. And so now, what do we need to do? We need to actually be going in here, right? So we need to be, so this will do the recursion, but then what you need to do is you need to pop afterwards, right? So it's append backtrack pop is like your main backtracking template. So cur.pop. And now I don't think we need anything else in the backtrack. Now I think we just need to call backtrack with index 0, and finally we need to return the result. So let's see how that goes. Let's see if we did. Okay, so no, that part's fine. Yeah, so it looks good. quite an efficient solution. And let's go through the time and space. And so let's talk about the time and space complexity here as well, right? So this is going to be a very inefficient algorithm for sure. But essentially at every single letter, you can have worst case 4 different choices, right? So it's worst case. So it's going to be 4 to the n, because at every single letter you can have worst case 4 choices, and then there are n letters, right? So like if you had 3 letters and each one has like, there's 4 choices here, 4 choices here, 4 choices here, it's 4 to the n, so this would be like 4 cubed. So it's 4 to the n. That's how many different combinations you have. Now also you want to think about how long it takes to build each combination. And so worst case, to build a combination, it actually takes n time, because even though for most of them it's faster, right? Like let's say you have 1, 2, 3, like let's say you have like 1, 2, 3, 1, 2, 3, and you have a 4, and now you change a 4 to a 5. That only was a big O of 1. But then what if your next combination is like, 2, 3, 4, 5? Now you have to rewrite the whole thing. So worst case scenario, this is going to be O of n to actually build a combination, and then in worst case, there are 4 to the n combinations. Now on average, obviously it's not quite as bad because there's only 2 numbers with 4 to the whatever complexity, but this is like worst case. And for the time, or for the space, it's actually going to be, so let's write time here. And for the space, it's actually going to be, you don't count the result, so it's just going to be the length of current, and current is the length of like n, where n is the length of digits essentially. And this is also the length of digits. So n times 4 to the n, and the space is O to the O of n, because you're not counting the result. If you did count the result, then you'd have to figure out like how long each letter is and stuff. But essentially, yeah. Space is the length of just the current, because that's the only non-variable you have. This is the only thing that you're actually saving memory to. Everything else is just like a local variable, right? I mean, I guess there's not too much. There's also this dictionary, but this dictionary is O of 1 because there's only 9 numbers and they only have 3, so this is all constant, so that doesn't count. Yeah, so it's this cur. I mean, obviously you can also argue this is O of 1 because cur is only 4 length. So you could argue space is O of 1 as well. You could argue like this is something else, but realistically, I would say O of 1 would be pretty reasonable just because the numbers are so small, or O of n. But this is never going to grow where this can grow, relative to your. I don't think you want to look at like the length of the constraint and just say like, oh, it's a small constraint, so let's not include it. That's probably not the best, because technically your constraint can grow. So this, if it does grow, then it is O of n, where like this will never grow regardless of, this is like all the letters possible. But yeah, that's going to be it for this one. If you like this one, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.